Hello, here we'll do a real life example. We're going to try to graph this quadratic function. It's a case of combined or mixed transformations. I know it's a quadratic because I see the square. So what I'm going to do is I'm going to start with the parent function, which is going to be the parent quadratic. And the parent quadratic will have the following chart that we have seen before, so I'm going to go fast here. 0, 1, -1, 2, -2 as input, 0, 1, 1, 4, 4 as output. Let's plot those points. It's going to be 0, 0, 1, 1, etc. That's the 0, 0, 1, 1, and it's symmetric about the vertical axis. -1, 1, 2, 4. Let's put this little line here too. You see every unit counts as 2 divisions, and -2 goes to 4 as well. If everything is done correctly, that should be symmetric about the y-axis, and then I connect it, and this is the original or parent function, and that's there it is, its graph. Now why do I need this? Because I need to compare the parent function with what's given. Let's do that, and I want to find the differences, and I see that if you compare the y equals x squared and y equals -3 x minus 4 squared plus 2, this one has an extra negative, an extra 3, an extra plus 2, and an extra -4. Well, let's see what each one of those does. Let's start with the plus 2. That plus 2 is not associated to x, so it's vertical. It's a vertical shift. It's a vertical shift. This -4 is associated to x, so that's a horizontal shift. Then this 3 multiplies, it's 3 times this parenthesis, so this is a stretch, and it's a vertical stretch. Then this negative, it's also vertical. It would be horizontal if it was attached to the x and it has its own parenthesis, or even without the parenthesis, because it's already inside the parenthesis. This negative in front of x would signify horizontal transformation. It's not in front of the x, so it's a vertical flip. I say I have 1 vertical, 2 vertical, 3 vertical transformations. Those have to be done in the correct order, otherwise I'll get the wrong graph. PEMDAS is going to determine that order. Okay, let's start with the vertical shift. It's plus 2, so this is an addition. So I have an addition in my PEMDAS. The horizontal is by itself. The order of that would matter only if there was another horizontal, and that would be relative to that other horizontal. But because it's by itself, I can put it in whatever order. It's not part of the PEMDAS. The vertical stretch is 3 times something, so that's a multiplication, and I have an m in the PEMDAS. Obviously multiplication goes before that. Now what about the flip? What is the flip? That I can think of it as multiplication as well. This negative means really negative 1 times 3. So this is also a multiplication. That means I have 2 multiplications and 1 addition on the vertical transformations. Those need to be done in an order according to PEMDAS. So first the multiplications, then the addition. Now, does it matter which multiplication I do first? No, it doesn't matter. So let's do the flip first. And I'll start with the parent function, which is the red one. And I'll do a vertical flip. Now, the vertex is not going to go anywhere. So the vertex stays there. But this point that is 1 unit above is going to go down until it reaches 1 unit below. So it will go here. I know by symmetry, since the vertex is here, there has to be a vertical axis of symmetry. And since this is 1 from the vertical axis, there has to be a point here. And that's consistent because that point, if it goes 1 below, it's going to end up where I expect it based on symmetry reasoning. Now, what about this one? That point is 4 up. It's going to go down. Make sure it's going to go in a straight line until it reaches 4 down. So it flips. It was 4 up, now it's 4 down. And that point is going to go in a symmetric location right here. Make sure that it's going straight down. It was 4 up, now it's 4 down. Okay, those are the points of what I'm getting when I do the flip. Let's connect those points. Make sure you do the vertex kinda rounded. And that is what I'm getting after I flip. Oops. Make sure you don't extend it more on one side than the other, and also in comparison with the parent function. Now, what would the equation for this function be? Well, it's what I used to have flipped. So the equation is what I used to have flipped. Okay. I have done this multiplication, so one of the 2 multiplications. Let's do the next one, which is times 3. Now that is a stretch, and I'm gonna apply it to whatever I have done so far. So I'm gonna apply the stretch to the blue function. Let's make it pink. It's times 3. Everything is multiplied times 3, meaning getting stretch. Okay, but what happens to the vertex? Well, you can't stretch 0, so the vertex still remains there. But this is 1 below. Now it's gonna go to 3 below. It's gonna go here. So this was 1 times 3, it's going to go to 3, it's going to go next to negative 3. Alright? Okay, now what happens to this one? I can see that it's 1 below, so it's going to go to 3 below, or I can see that this point is 1 from the axis of symmetry, which goes through its vertex. There has to be another point here that's 1 on the other side of the axis of symmetry. Either way you want to do it, there's going to be a point there. if you count points 1, 2, 3, etc., just double check that it's in symmetric location with respect to the axis of symmetry. It's really easy to make a mistake. Okay, now what about this point here? That point is 1, 2, 3, 4 below. Now, times 3 is going to have to go to 12 below. Okay, where is the 12? Now if 10 is here, then I have 1, 2, here is the 12, and that is going to be the level of this point as it goes down. Make sure you go on a straight line and stop at 12, and that's going to give you a new point. So that point became that point. It stretched 3 times, so it goes from the 4, which is -4, goes to -12. Maybe I should emphasize here that those 5, that's also a -5, that's a -10 because it's below the ground. Okay, now what happens to this point? Well, it's gonna go down, and I can count to 12 along this line, so it's gonna go like this. When it reaches 12, it's gonna stop. It was at 4, -4 really, it goes to -12. Another way to do that is notice that this point is 1, 2 to the left of the axis of symmetry, so there has to be a point at 1, 2 to the right of the axis of symmetry, which is basically that point becoming 3 times taller, but below the ground. Now let's connect all those points carefully. And the other branch. So what I have done now, I have multiplied 3 the blue one. So the pink one is whatever the blue used to be, but times 3. So this is the equation of the pink one. I have, in a sense, done this part, and now I'll do the last vertical transformation. I'm done with the 2 multiplications, so now I will do the addition. The addition again is vertical shift, vertical transformation, so everything goes up by 2. I won't have to move all the points, just the representative points, which is the pink vertex. Goes 1, 2, so it goes here. Again, emphasis that I first did the multiplications and now I do the addition. So I did the 2 multiplications and now I do the addition. Okay, so the vertex goes from here to there. I shift 1, 2 steps, and it goes up. Okay, now what's going to happen to those 2 points? They're going to go 2 units up, 1, 2, so that's going to go here. What about this one? It's going to go 2 units up, 1, 2, it's going to go here. Double check that they are symmetric. If that's the vertex, the axis of symmetry goes through the vertex, and this is 1 unit to the left. There has to be another point that's 1 unit to the right, and everything is consistent. How about those 2 points now? Well, they're gonna go 2 units up, so it's gonna be 1, 2 right there, and then 1, 2, which is right there. Let's check that it's symmetric with respect to the y-axis. This point is 1, 2 to the left. There has to be a point that's 2 to the right. 1, 2, there is 1. and those, and everything looks good. So let's connect. Now don't start with the from the origin because the vertex is elsewhere. Oops. Oh no. Okay, what I have done now, I started with the pink and I went 2 steps up. What would the equation for the orange one? Is whatever used to be for the pink plus 2 steps up. Now it kinda look like the one that I want to graph, but there is the -4 missing. That -4 is a horizontal shift. I can put it at the end, I could have put it in the beginning, in the middle, it doesn't matter. The order of that, it doesn't matter. So I'm just gonna put it now at the end. And what is that now? It's a horizontal shift. Now common sense is telling me that since you subtract 4 you should go to the left, but we reverse the logic when it comes to horizontal transformation. I'll do the opposite. Instead of going to the left, which is what common sense is telling me, I'm gonna go against that. I'm gonna go to the right 4 steps and see what happens. Alright, let's start with the vertex. It's gonna go 4 steps to the right. 1, 2, 3, 4. So it will end up going here. Now this is a horizontal transformation and everything needs to be at the same vertical level. Alright, now where would that go? It's gonna go 4 steps. So it's gonna be go here 1, 2, 3, 4, and we'll end up going there. Now where is the next, where does this point go? I can find this 2 ways. First of all, since this is the vertex, there is an axis of symmetry, and that's the axis of symmetry. This point is 1 unit to the right, so there has to be a point that's 1 unit to the left, and that is where this point will have to go. Let's count. 1, 2, 3, 4. So that looks good. Double check because it's really easy to make a mistake. Oops. Okay, now let's continue with the next point. The next point is this point, and I'll count 4 steps. 1, 2, 3, 4. So it will end up right there. I will find where this point goes, and I'll find it 2 ways. First, I'll do something that's probably easier. I'm gonna use symmetries. So here's the axis of symmetry. That point here is 2 units, as you see, 1, 2 units to the right. There has to be a point that is 2 units to the left. 1, 2. So if everything is good, that point will go here, which is 1, 2 units to the right. Now let's see, I'll start with that point and I'll measure, I'll count 4 steps to the right. 1, 2, 3, 4, and it goes where I have already figured out. So I did it 2 ways. That means chances is that I did it correctly. Let's connect all the points. Now what I have done now is the green graph and I started from the orange one that has this as an equation, and what I did, I moved to the right 4 steps. So the equation that describes the green graph is this one. Y is equal to whatever you have on the orange, but instead of x, since I move to the right, it's going to be x minus 4, and the rest is the same, so it's plus 2. And if you compare this with what I wanted to graph, I have graphed it, and that's the graph of negative 3 x minus 4 squared plus 2. Alright, that's it.